So we got 2 days worth of, or actually what we're going to do is we're going to do 3 days worth of work in 2 days, okay? Because Friday we took a vacation. All right, so a much needed one, but nonetheless a vacation. So let's finish what we didn't do on Friday. It wasn't a lot, so I don't think it'll be a big deal for you guys. So first of all, I want you to take this polynomial. Okay, and I want you to put it in standard form. What does that mean? Vertex form. Okay, this is like the test is going to be. It's going to have 3 blanks over here, no calculator. This is going to be in standard form, and then I want you to tell me what the vertex is, and I'll tell you what the third blank is in a minute. So I'll give you 2 minutes. Let's go. You should be completing the square on it, guys. We did this. This is where you're going to write your equation. This is where you're going to tell me what the vertex is, and then I'll tell you what this point's for in a minute. Okay, are you ready? All right. What should be the first thing you should do? Yeah, you cannot complete the square unless the coefficient of the quadratic term is 1. In other words, it has to be a 1x squared. So you take the 2 out. Do you take it out of everybody? No. Only out of the x's, right? So it's going to be x squared minus what? 4x. And anytime you take something out, you need to draw the rainbow. Because if you don't, you will forget to take that 2 into consideration. Okay? So now I'm going to take half of 4 is, and 2 squared is, so this is plus 4. But that's when you look at the rainbow and you say, oh, did I really add 4? What did you really do? Added 8. So what do I have to do out here? Subtract 8. Very good. So this is going to be 2 times. I write this as a binomial squared, so it'll be square root of the first, keep the sign, and square root of the last. Quantity squared. This number will also always be half of this. Okay? And then 32 minus 8 is 24. So that's what goes in this equation right here, or this line. F of x is equal to 2 times x minus 2 quantity squared plus 24. What's my vertex? 224. Remember how we said you change the sign? Keep the sign. All right, this blank, what they're going to ask you to do is find the X-Intercepts. Guys, listen to me. You could go up here and try to factor it, but here's the problem. Not everything factors, right? So then you could say, well, I could go up here and I could always use the quadratic formula, right? But, guys, if you have this problem right here already worked, why not just use it? Set it equal to 0 and solve for x. It is so easy. You have set it up to solve it. All right, so what should I do first? Minus 24. Very good. From both sides. So this is 0 minus 24, so it's negative 24. Now what am I going to do? You could have told me at what?
It opens up, and the vertex is at
Oh, it's not going to call them X-Intercepts. It's going to call them answers or solutions or whatever. So if, like what Trey says is true, it opens up and its vertex is above the x-axis. Do you see what he's noticing right off the bat? What kind of answers am I going to get? Huh? Imaginary. Very good. What do we call imaginary after Algebra 2? Very good. Complex. They're going to be complex. Okay? That's imaginary. All right. Now what am I going to do over here? I'm back over here now. Divide by 2. All right? So then I'll get negative 12 is equal to x minus 2 quantity squared. Now what do I do? Square root both sides. Anytime you're solving an equation and you take a square root, you have to put plus or minus. Is there a perfect square that's a factor of 12? 4. So I'm going to put the negative on the 4 and then times 3. What's the square root of negative 4? 2i. What's the common mistake? To say what? Negative 2. Okay? You see how kids will do that? That's what their brains are doing. They're saying, oh, yeah, the square root of negative 4 is negative 2. No, it's not. The square root of negative 4 says, oh, you're going to have an imaginary root. That's an imaginary. All right. Is equal to, these just cancel each other out, and you're left with x minus 2. Now I'm solving for x, so what do I do? Very good. And where does that 2 go? At the end or in the beginning? Yeah, it goes at the beginning, guys. Don't put it back there. It looks crazy and weird, like you don't know what you're doing. Okay? So, it actually, x, these cancel, is equal to 2 plus or minus 2i square root of 3. Now, had I used the quadratic formula, would I get that? Yeah, you would, people. You would. I'll do it really fast for you, but I'm not going to let you work it and me follow you, okay? So remember that the quadratic formula is x is equal to, there was a negative boy who was kind of iffy to a radical party. Very good. Okay, so obviously it has to be this equation. Could I use this equation? Look, if this is that equation right there, well, no, pardon me. Could I do this? Not that, sorry. I looked at taking the 2 out. Could I take the 2 out and x squared minus 4x plus 16? Could I use this equation or this equation? Yes, because you're setting it equal to 0 and you could divide the 2 out. Okay? But let's say nobody knew that. So they just went up here and they said the opposite of negative 8 is positive 8. Plus or minus the square root of 8 squared, 64, minus 4 times a is 2 times c is 32. All right, so that's 64. Let's see, 8 times 32, 16, carry 1, 256. What's 64 minus 256? 192? Okay, so that's negative 192 all over 2 times 2. All right. What's a perfect square that goes into 192 evenly? 81? I don't think so. 4 does, but if 4 works, what did I tell you? Always try 16. It is 16 times, what? 16 times 12? That tells me there's another one in there, but we'll just do it one time. We'll say negative 16 times 12. All right. Yes, it is. 36 is in there. So now, wait a minute. Did I do that right? What is 256 minus 64? I did that in my head.
What do you mean 64? 192.
It is 192? Okay, thank you. All right. So this is 8 plus or minus the square root of negative 16 is 4i square root of 12 all over 4. Okay, 64 times 3. That's what I was looking for. All right. So this is 4 times 3, right? What's the square root of 4? I take it outside and do what? Multiply it by that. So then it becomes 8 plus or minus 8i square root of 3 over 4. Now what do I need to do?
Divide by 4.
And there is that answer over there. Now which one was easier to get? The one on the left. Oh my word, that was a lot of stuff. Okay? So, this is an easier way to do the problem. It's not the only way to do the problem, but it is an easy way. Alright, everybody okay?
Oh, yeah.
Okay. So, now look, that's that other blank on your test. Okay, just blank right here. He's asking for the solution, so then you would write in there 2 plus or minus 2i square root of 3. Okay, it's going to be 3 problems like that. Do you have a calculator? No, you do not have a calculator. Okay, and then there's going to be 3 other problems, and I hope I'll get to them today, but if I don't, I will tomorrow. All right, so not on the first part of the test. Oh, well. Okay. So, let's do this one. That's exactly right. Normally it's just problems like...
No, you think it's easy.
I feel like I could have done it with a calculator. Yeah, I got it with a calculator wasn't the fault. The part with calculator was really easy. But the stuff without, and then, like, most of it I didn't even know.
That's because most of the stuff without a calculator, it's not the math computations, it's a lot of thinking problems. It's a lot of thinking.
Big numbers divided by big numbers takes you too long. You only have
That's true. It's time.
25 minutes.
I know, but at least we're getting better about timing y'all on certain things. Because when I first moved here, y'all didn't time anybody on anything. All right. Here's our next skill. Write an equation. Okay, guys, listen up. We're going to write an equation. So I could either do one of 2 things. I could give you a picture of the parabola, or I could just give you the information. Okay, so obviously I'm going to draw you a picture. So I'm going to tell you its vertex is at 1, 2. Now, how many parabolas have a vertex at 1, 2? Several thousand. How about an infinite number, right? Because I can make them really, really fat, just kind of fat, very skinny, or not so skinny. I can make them up and up, or I can make them up and down. You see what I'm saying? So there's an infinite number. Now, how many parabolas have a vertex at 1, 2 and pass through the point? Uh-oh, I need another line. Pass through the point 3, negative 6. Only one. Okay? Only one. So that's the equation, that's the parabola that we're going to write the equation for this parabola. Okay? Now, listen. That's exactly what that says. Okay? It says find A first. So what do some of the kids, what did they read? Find a first. And they're like, okay, well, what's a first, Miss Davis? I'm like, what? So here's your equation. Y is equal to A times X minus H, quantity squared, plus K. What does that direction say? You've got to find A first. Now looking at this parabola, what kind of number do I know A is going to be? It's going to be negative because this thing opens down. Okay? So, look. What is this? What's this? What's it called? In that formula, what is it? H and K. He is H and K. This is just a point on the parabola. What is he? No. He's what? Yeah. He's just my X and a Y. Okay? Now look, if I put in the H and the K and the X and the Y, what's the only thing you have left? So then you can find it. Alright? What is Y? Negative 6 is equal to, I'm looking for A. What's X? minus, what's h?
Would it be the opposite?
1. It is, minus 1. Okay, the formula is x minus. That's what's making it the opposite. Quantity squared plus 2. Okay, don't go by looks. Please don't go by looks. All right, what's 3 minus 1? What's 2 squared? 4. So negative 6 is equal to what? 4a. Don't write a4. You write a4, your brain goes, what? What? And you're liable to add 2 to that 4. Okay? So don't write a4. You write 4a. That's the way you've always been taught. Now what do? I subtract 2 from both sides. Alright, what's negative 6 minus 2? Is equal to 4a. Now what am I going to do? And what is a? So now can you write your equation? Yeah. Y is equal to negative 2 times x minus 1 quantity squared plus 2. Okay? Anybody got a question? Could I check this? Oh, people, you can plug that in your little calculator, and you could find the maximum. That's what it would be. And you could see, look on your T-chart and see if that point was on it. Okay? Well, on part of the test, you won't have a calculator. Look, the very first thing I'm going to do is give you a pink piece of paper. It's going to have 3 problems like this that are going to say, put it in standard form, tell me the vertex, and tell me the solution. Okay? Could be. Okay? I'd say if I worked one, you might see one too. Alright. Now, let's talk a little bit about today. Okay? So, still in 2.1, and there are 3 examples similar to this, but I'm only going to work one of them. Okay? The other kids, I only worked one problem, because I think it's pretty much stuff we've already talked about, so I don't think you'll have a big problem with it. Alright, so first one says, a baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second and at an angle of 45 degrees with respect to the ground. The path that the baseball takes is given by this function, negative 0.0032 x squared plus x plus 3. Okay, so I'm not going to talk a lot about this, but I just want you to understand, this is not the same formula that you have seen before that looks like this. Okay? This is a formula that relates height with time. Okay? This is not doing the same thing. That's why it doesn't have that minus 16 up there. And remember, it said it was hit at a velocity of 100. That's why the 100's not here. Okay? Because it's not relating height and time. So listen to what it says. The path of the baseball is given by this function where f of x is the height in feet and x is the distance from home plate in feet. Okay, so you see the difference in the two? This one's relating height with respect to distance, how far it went. The other one was talking about height with respect to time. Okay, so that's why this one looks a little bit different if you notice that. Okay, so it wants to know what is the maximum height. Okay, so it's a real life problem. So what's the easiest place to solve it? On your calculator, okay? Real life problems. Well, I'll plug those dudes in the calculator. Alright, so I'm going to take my little calculator. I'm going to go to y equals, and here is my problem plugged into y equals negative 0.0032 x squared plus x plus 3. Now, I'm not going to just go graph, and I'm not going to go zoom fit, because I think it's important that kids learn how to go to their windows and at least set a reasonable window. Okay, what does X represent? No, distance from home plate. So what's it going to start at? 0. And what do you think that it might be the maximum distance? 3, because somewhere between 3 and 400, right? Because that's where the fence is, all right? So I'd say 3 to 400 was a good one, so let's say 300. If I say 300 and it's not long enough, then I can always come back and change it, right? What do you want to go by? I'm going to go by 30, just because it's divisible by 10, so I just divided by 10, okay? So, but you could go by 25s or something like that. I'm okay with that. All right, Y, what does the Y represent? The height of something, okay? So what's the minimum? 0, okay? Or, yeah, 3. But I could use 0 because what if I was asking how far out was it when it hit the ground? Okay? Then I would need to know that 0, right? My maximum. What do you think the maximum? Someone said last period 1,000. That's crazy, isn't it? I said, if you can hit the ball 1,000 feet in the air, you need to go to batting practice, because we could apply that strength in a different way, and you could be phenomenal and make millions of dollars for your life, right? And someone said, well, if I hit it 1,000 feet in the air, Miss Davis, nobody could catch it. And I'm like, maybe so. Probably not. All right. So, yeah, it is. All right. So what do you think is a good maximum? 100, 200, so let's say 150. That'll go right in the middle for you. Okay? And I'm going to go by, guess what? 15. So, was 100 a good guess? Yeah, 100 would be okay. Okay? 100 was very, very good. All right. So, now what if I asked you how far did the ball go before it hit the ground? Are my windows sufficient? No, you would have to extend who? Your X what? Max, right? Your X max, you'd have to go out farther. All right, so I'm going to find, what's that called? The max. So I'm going to go second and calculate. I'm going to choose number 4, which is a maximum. He's going to ask me for some directions. He says, give me a left bound. Boom. Then he's going, give me a right bound. There it is. I don't want to guess. So there's my answer. Okay? Now, what is the maximum height of the baseball? 81. Very good. This is another one of those things where you have to understand what the X is telling you and what is the Y. If the Y is telling me the height, the highest that it went, what's the X telling you? The distance what? From home plate. You can't just say the distance, guys. The distance what? From the moon? The distance from what? From the school? See what I'm saying? From the second baseman? No. It's the distance from home plate. It's 156.25 feet from home plate when it reaches its maximum height of 81.125 feet. Alright, everybody okay? Okay, so let's talk about end behavior. Okay? Let's talk about end behavior. That's right. Now look, you have this in Algebra 2. You have this in Algebra 2. So first of all, you tell me, how do I tell what is the degree of a polynomial? The highest exponent. Okay? The highest exponent is his degree. Now, when I talk about this degree, and I'm talking about the highest exponent, then it can be either an even number, an even degree. Come on, y'all gotta read my mind. An even degree, or it could be an odd degree. Okay? Obviously, even degree would be 2s, 4s, 6s. I can't talk and write at the same time. And an odd degree would be 1, 3, 5, 7, things like that. Okay, So tell me about an even degree polynomial. What do you know about his end behavior? That's exactly right. An even degree polynomial will begin and end in the same direction. Okay? Begin and end in the same direction. Now let's talk about odd. I just have to remember one of them, right? I mean, so odd's the one that if I had to pick one to remember, I would pick odd. Because if you say, ooh, that person's odd, all it means is that they are different from you. Okay? Do they probably think you're odd? Yeah, because you're different from them. Okay? So an odd degree polynomial, they begin and end how? In different directions. Okay? So let's do an even degree polynomial. Alright? Let's talk about even. Okay? Now, if I'm talking about an even degree polynomial, and then his leading coefficient. Now, when I say leading coefficient, you have to know what I'm talking about. That is the coefficient of the highest exponent, okay? So it can either be positive or it could be what? Negative. All right, so let's just take a look at them. All right. Now, the sign of the leading coefficient tells you where he ends up going. And since we read from left to right, he's actually telling you the right-hand behavior. Does everybody understand that? Okay, so obviously the right-hand behavior is on the right, and the left-hand behavior is on the left. Now, this will also be questions on the pink part of the test that you are not allowed to use a calculator on, okay? So they're not going to give you a picture because that would be crazy. They're going to give you a polynomial, okay, and they're going to ask you, tell me about his right-hand behavior and his left-hand behavior. They're just asking you, do you know about end behavior? What could I do to this if I give you a polynomial to mess you up, to make you, for me to really know, do you know what you're talking about? Or
if you put like x squared plus x to the third.
There you go.
Plus x to the fourth.
You don't put it in that standard form where you start with the highest exponent and then go down. I put it out of order, okay? That makes me know, do they really know what a leading coefficient is? Okay, so look at this guy right here. No. Look at this guy right here. Tell me what his right-hand behavior is. Oh, here's the words you can use. Sorry. Okay, so you can only use the word rises or falls. Okay? Those are the only words that you can use. So, right-hand behavior, rises or falls? Very good. Left-hand behavior, rises or falls? Okay, so now we're going to write it the other way. You did this in Algebra 2, and in Algebra 2 it was difficult. It won't be near as hard this year if you learned how to do it last year. Okay? So, here's the deal. This is the y's, right? If they go up, they're approaching positive infinity. If they go down, they're approaching negative infinity. These are the x's. If they go to the right, they're approaching. If they go to the left, they're approaching. Very good. So here's what it looks like. It says f of x, what's that another word for? Y. F of x approaches what? On this side. Positive infinity. As x approaches, I'm on the right, people, with x approaching. Very good. Okay?
Hey, isn't the exponent thing have something to do with the constant though?
Yes, it is. We're going to talk about that, but we won't get to it today. All right, let's look over here on the left-hand side. F of x approaches what? Positive infinity. As x approaches, very good. On the left, negative infinity. Okay, so let's look at this one over here.
I didn't do any of this right last year.
Well, let's get it right this year. Okay? Still, he has a right-hand behavior and a left-hand behavior. All right? Right hand, what's this thing doing? Rising or falling? So let's say falls. On the left hand, what's he doing? Falls. Okay, so let's do the other way. All right? On the test without a calculator, all I want are the words rises or falls. Don't say up or down. Don't say positive infinity or negative infinity. I just want the word rises or falls. Okay? Over here, f of x approaches what? Negative infinity as x approaches positive infinity. I'm on the right. Huh? No. Over here, f of x approaches negative infinity as x, yes, that was the bell, approaches negative infinity.